It says determine all the measures of all the angles in standard position, so good thing we know that definition already, between -800 and 800 that are coterminal with 85 degrees. So we're going to draw a picture of this. 85 degrees would be right here. We can label it 85 degrees. When listing all the coterminal ones between -800 and 800 with 85, we would also include 85. So when we're doing coterminal angles with 85, we would include 85 because, 85 ends in the same place as 85. Now, this second one that I'm going to draw here, again, it starts on the positive x-axis because it's in standard position. How would we find that one? Well, we're going all the way around, which is 360 plus another 85. So if I do 360 plus 85, I get 445 degrees. If I added 360 again to this, does it make sense that you could add 360 wherever you are and you'd end in the same place again? You just did one complete rotation. So if I added 360 to 445 again, I would get 805 degrees. And 805 degrees is coterminal with 85, but if we read our question, we're only supposed to go up to 800. So this one is too far. And we only have those two positive angles to start with. Going around in the negative direction, I could figure out this one by subtracting 360 degrees from 85. And if I subtract 360 degrees from 85, I would get negative 275 degrees. That would be the red one. And if I subtracted 360 again from that one, ooh, you might get hypnotized with this one again. Wow. Yeah, this diagram, I don't know if it will help you later understand what you did. It just, that's when I got dizzy in math. But if I subtract 360 again from 275, I'm going to get negative 635 degrees. And you might see that if you subtracted 360 again, you'd be past negative 800. So there's only 4 angles coterminal between negative 800 and 800 with 85 degrees. Part A, done. Part B. Write an expression for all the angles. So now we wrote the first 4. Now we want to write the rest of them if there were no restrictions. Can you see that there's an infinite amount? I'm sorry, this class might go a long time if we have to write them all down and there's an infinite amount. It's like detention. Write down all the coterminal angles. Tell me when you're done. Oh, you missed one. Keep going. Okay, no. So in math, we have to figure out how do we write an infinite amount of things without having to write them all down, because that would take forever, literally. Well, we say, what was happening here? What's the pattern that we're doing? Right, we started with 85. We could add 360 once to get 445, add 360 again to get 805, add 360 again, add 360 again. We could keep adding 360 and get all of the positive ones. And we could keep subtracting 360 and get all of the negative ones. And so the way that we show this is we say, I'm going to start with 85 degrees. I'm going to add 360 degrees as many times as I want. So I'm going to say, I'm going to multiply it by k. And I need to define what k is, because I can add 360 once, I can add 360 twice, 3, 4, 5. I can't add 360 1.5 times. That doesn't work. I can't add it 1.732 times or anything like that. They have to be adding whole numbers, or I could subtract whole numbers, right? I could subtract 361, subtract 360 twice. So what are those numbers called if k can be 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5? What do we call those numbers? Integers. Do you remember the symbol? So we go comma, and then we define k belongs to the integers. Do you remember the symbol for integers? Okay, real numbers was that r, because real numbers starts with r. Yeah, North America, they do I sometimes for North American students who can barely spell and say integers start with I, that's good. But the international symbol for integers is a Z. It comes from the German word Zahlen for numbers. Okay, so yeah, because it's not like, oh, they screwed up and made a crooked I or anything like that. No, it is supposed to be a Z. And so we say we can add 360 degrees, positive or negative amount of times, as many ways as we want, and that would give us all of them. Okay, questions for practice 4 and 5. It's supposed to be the double line, just like the real numbers is like that. Whole number or rational numbers from Q for quotient are like that.
Does it all come from the German?
No, like Q is for quotient, because a rational number is a fraction and a quotient is dividing. Our real numbers, just the integers. Natural numbers, I'll make it up. It comes from the French word naturel. I don't know. Yeah, 4 and 5, and I was going to get to the 3 big ideas of this unit, but instead I'm going to give you some time to work.